Hi friends, welcome back to my channel. This is Lokesh Babu. Thank you for watching my videos. So in the previous video, we discussed about what is a Cayley-Hamilton theorem and how to verify Cayley-Hamilton theorem by using this problem 1423. Okay. So in that we know how to verify the Cayley-Hamilton theorem, right? By using the characteristic equation. Then now let us take one more different problem. Find the eigenvalue of this matrix. See, let us solve eigenvalue of this. To find the eigenvalue, we need characteristic equation of this matrix A. That is A minus lambda I equal to 0. That is 1 minus lambda, 4, 2 and 3 minus lambda. This is the characteristic equation, right? Now, since it is 2 by 2 matrix, you know the formula. What is the formula for this? Lambda square minus s1 lambda plus s2 equal to 0, where s1 is the sum of the principal diagonal elements. It means simply I can write trace. S1 is the trace, sum of the principal diagonal elements, and s2 is the determinant of A. What is s1? Sum of the principal diagonal elements. 3 plus 1, 4. What is the determinant of this? 3 minus 8. This is 3 minus 8. This is equal to minus 5. Right? So substitute here lambda square minus 4 lambda minus 5 equal to 0. Minus 5 into 1 minus 5. So find the factors. 5 on the 5, minus into plus minus. By adding this you will get minus 4 lambda. This implies what you will get? Lambda square minus 5 lambda plus lambda minus 5 equal to 0. This implies lambda common, lambda minus 5 plus lambda 1 common, then lambda minus 5 equal to 0 implies lambda minus 5 and lambda plus 1. Lambda minus 5 and lambda plus 1 equal to 0 implies lambda equal to 5 comma minus 1. So these are the eigenvalues. Lambda equal to 5 comma minus 1 are the eigenvalues, right? Now let us find its inverse by using Cayley-Hamilton theorem. Okay, inverse by Cayley-Hamilton theorem. Inverse by Cayley-Hamilton theorem. So I told in the previous lecture, to find the inverse, A inverse, we have to multiply the characteristic equation. What is the characteristic equation? So this is the characteristic equation. The characteristic equation with A inverse. If you want to find A inverse, inverse means find A inverse. To find this A inverse, then multiply this equation with A inverse. What is this equation? Since it is by Cayley-Hamilton theorem, A should satisfy its characteristic equation. Therefore, in the place of lambda, what I will write? I can put lambda equal to A. Right? Then what is this? A square. Then this is A square minus 4A minus 5 into, you can write I is equal to 0 because you are multiplying with A. This implies A inverse into A square minus 4 A inverse into A minus 5 A inverse into I equal to 0. Implies A inverse into A power minus 1 plus 2 is minus 1 plus 2 is 1. Minus 4 into A inverse into A minus 1 plus 1 0. A power 0 is 1. So simply 4I. Minus 5 into A inverse into I is A inverse only. Sorry, 5 A inverse is equal to 0. This implies I want 5 inverse. Bring this side or that side. 5 A inverse is equal to 5 A inverse will become positive equal to A minus 4I. So implies A inverse is equal to A minus 4I by 5. So 1 by 5 into A minus 4I. 1 by 5 into A minus 4I is equal to 1 by 5 into A. What is A? 1, 4, 2, 3. This is A. minus 4 into I is 1001, right? This is equal to 1 by 5 into, what is this? 1423 minus 4004. This is equal to 1 by 5 into, what is this? 1 minus 4. 1 minus 4 is minus 3. 4 minus 0 is 0. 2 minus 0 is 2. 3 minus 4 is minus 1. So this is the A inverse. If you want to find A inverse, this is the A inverse by using Cayley-Hamilton theorem. This is okay. We can find A inverse by using adjoint by determinant of A, but using Cayley-Hamilton theorem you can prove like this. Okay. Next one is express this as a linear polynomial. Linear means power 1. So express this one as a linear polynomial. Okay. So let us see. So let us express this as a linear polynomial. What is this given? Given expression is a power 5 minus 4a power 4 minus 7a cube plus 11a square minus a minus 10i. We want to express this one as a linear polynomial. See here, very interesting, easy but a little bit confusion, so concentrate. So I can write this one as a power 5 minus 4 a power 4 minus this 7a cube. I can write minus 2a cube minus 5a cube. Can I write like this? Minus 2 minus 5 is minus 7, no problem, plus 11a square minus a minus 10i. Just I want to rewriting this. So already, what is our characteristic equation? Our characteristic equation is, what you will get? A square minus 4 a square minus 4a minus 5i. No, this is the characteristic equation, because lambda square minus 4 lambda minus 5, right? Characteristic equation, lambda square minus s1 lambda, so minus 4 lambda plus means minus 5a, right? So I want to utilize this. I want to utilize this characteristic equation in this equation. Let us see. I will take a cube common from this. If I take a cube common from this, sorry, if I take a cube common from this, what you will get? A square minus 4a, because a cube common. Now I want 5i from this. A cube is common, then minus 5. So simply I can write minus 5i, since it is minus 5. Now what is this? A power 5 is over, and this finish. What is remaining? Minus 2a cube plus 11a square minus a minus 10i. Right? Now what is this? A square minus 4a plus 5i value is 0. This value is 0. So this completely, this total a cube into 0 is 0. So this is equal to 0, this one. Minus next 2a cube into, again I want to bring from this the same equation. How? 11a square I can write here 8a square plus 3a square, this one, because I want if I take 2a common, 4 and 5 also I require 3a square, and minus a for 11a square I can bring like this, and minus a I want to split. How can I split? I want 4 and 5. Next minus 12a plus 11a. Can I write like this? Minus 12 plus 11. What is this? Minus a only, minus 12 plus 11. Let us see whether it is useful or not. This is equal to, again I will take minus 2a common. If I take minus 2a common, then a square minus 2a square minus into minus plus 4a square minus into, which is useful, from this I can write otherwise 11 minus 10 I will write otherwise. So I want 5, therefore it depends on the problem, right? You can choose. A is, I can write minus 11a plus 10a. I can write, no, because I want minus 5, that is why I am changing. Okay, keep in mind that minus 5. If it is a different question, keep the characteristic equation in mind and you can change these values. That's all. So a square minus 4a minus into minus plus 2 4 the 8a square. Next I want 5. So 10 is there. So minus into minus plus 2 5s are 10i. Finish. So 10a also finish. This is also finish. Okay. Minus 2a square minus plus 8a minus to minus plus 10a. Now what is remaining next? 1 2 3 so next plus 3a square and minus 11a minus 10i is remaining. Now what is this? A square minus 4a, 5a value is 0. So this total is 0. Right? 0 plus something. Now let us take this one next. 3a square minus 11a minus 10i. So from this again, I want this a square minus 4a. How? If I take 3 common, then I want 12 here. So minus 11a, I can write this one as minus 12a plus 11a plus a. Can I write? Because minus 12 plus 1a is nothing but minus 11a. Minus 10 into I. Now I can take 3 common from this. Then I will take a square minus 3 plus into minus 3 4 the 12 a and I want 5 now. If you want 5 is not there, but minus 10 is there. So I can write this minus 10. How can I write? Tell me anybody. Minus 15i plus 5i. Can I write? Minus 10 you can split like this. Minus 15 plus 5i. 11 you can split like this. So depends on our requirement. 4a. From this 3 5s are minus 5i. Finish. So 3a square 4 and this is finished. Then what is the remaining? 1 2 0. A plus 5i is remaining. This is 0, you know. So what is this finally? A plus 5 into I. So which is a linear polynomial because the matrix power is 1. So this is a linear polynomial. See how is it? So if any matrix is given, you know how to find eigenvalues by using characteristic equation. You know how to find inverse also. Just now we discussed. Multiply with A inverse to the characteristic equation and verify Cayley-Hamilton theorem means just find out what in that equation a square is there. Find out a square and a and substitute. If it is equal to 0, then it verifying Cayley-Hamilton theorem. And if any polynomial is given like this, we can according to based on your characteristic equation, you can split this and you can find this, right? So I think it is useful for you. Thank you for watching video.